multiplying polynomials. In the past we've already talked about how I can add and subtract polynomials. What we need for that is we need two polynomials that have like terms. So when you're adding polynomials, let's say we had 3x squared plus 5x added to 5x squared minus 3x. I look at the parts that I have the same. I have 3x squared and 5x squared. So 3x squared plus 5x squared. I group those together. And 5x is added with negative 3x. And so then I would just combine like terms again. So then I get 8x squared plus 2x. So this is just a little review of what we've done in the past. If I subtracted the two, you need to remember that if this changes to subtraction instead of addition, then I would have to take that negative and distribute it in. So this would become a minus 5x, and it would become then a positive 3x. And your answer would be negative 2x squared plus 8x. So that is kind of where we came from, and now we're going to talk about what you should have done in class. So in class, you were supposed to explore kind of what happens when I multiply things. It was a little bit of a review from the past, where if I take two numbers and multiply them, that's pretty simple, right? 2 times 3 is 6. And this is pretty simple for you guys too, I think. This is the same as saying I have 3x plus 3x. 2 times 3x is the same as 3x plus 3x, which is the same as 6x. You could do the shortcut and just multiply the 2 and 3 to get your 6, and then multiply by x to get your 6x. And the same thing goes if I had 2 times 3x squared. This would just be 6x squared. This should be a little bit of a review for you. What we're doing here is we're multiplying what we call a monomial with another monomial. It's just one term. There's no addition or subtraction between the terms. That's all this is, monomial. And what you're doing here is what we call a simplified version of the distributive property. So when we multiply monomials, you just multiply the things that are the same. So if I instead had, let's see, 5x times 2x, this says 5 times 2 times x times x. 5 times 2 is 10. X times x is x squared. So my answer would be 10x squared. You can write it out in the step that I showed, or you can just remember 5 and 2 give you 10, and x gives you x squared. And then you multiply those together. So this is still a monomial times a monomial. Okay, monomial times a monomial. So what happens when we take a monomial and multiply it times a binomial? Well, bi means 2. So we're talking about 2 terms here. So when we take a monomial like 5 and multiply it by something else that has 2 terms, we're either going to have addition in here or we're going to have subtraction. So let's just say I have 3x minus 2 inside. What we're going to use is the distributive property. So we're going to take this 5 and multiply it to 3x. And then we're going to multiply it to negative 2. So this and we're going to put addition between them because I have the subtraction above. So this would be, and because 5 is positive, so that's why it's a plus 5 times a negative 2, not a minus 5 times a negative 2. It's because 5 is positive. So then 5 times 3x gives me 15x, and 5 times negative 2 is negative 10, so this is just going to be minus 10. So that's how you multiply a monomial and a binomial together. This still works if I change it from just a number to a number and a letter, like 4x times 6x minus or plus 3. I'm going to distribute both of my, I'm going to distribute 4x to both 6x and 3. So this gives me 4 times 6 times x plus 4 times 3 times x. And what this gives me is 24x squared plus 12x. And so that's the answer for that situation. And so in class, you were supposed to take these steps and then apply them in a more complex situation. So let's look at some information. Some terms you might need to know are kind of what we've been talking about. A monomial is just a number or a letter, or both together. So some examples of that are 5x, 3y, 5ab, etc. These are all, actually I don't like 5ab, but whatever. We'll do 6ab instead. And so these are all examples of monomials. They're just one term where I'm multiplying each of the parts together. A binomial, exactly how it sounds. It's two terms. Where a monomial is one term, a binomial has two terms. And those terms are each monomials by themselves. So some examples. 5 plus x is a binomial, or you could do x plus 3y is a binomial. You could also do 6ab plus 12, also a binomial. The reason they're all binomials is they each have two terms. 1, 2, 1, 2, 1, 2. Now, I've only written addition here, but this works with addition and subtraction. So if I change this to a minus 12, this works as well. If I change this to x minus 3y, this also works. Okay? So that's a binomial. So my next question would be, what's a trinomial? Well, tri sounds like a triangle, and a triangle has 3 sides, so this is going to have 3 terms. So some examples of that are x squared plus 2x plus 1. That's an example. Or 4x squared minus 2x plus 6. That's also another example, but you can't really see that because my logo. So I'm going to move that up just a bit. There you go. So these are 2 different examples. I've got addition and subtraction in each. But you'll notice I have 3 different things being added and subtracted. Okay, and it doesn't have to be just a square. I could take that square, and instead of squared, it could be cubed. Or I could make this 2x squared instead of negative 2x squared. So we got monomial, we got binomial, and we have trinomial. When you put them all together, you have what we call a polynomial. And a polynomial means many terms. And basically, that means more than one. So, when we say monomial, we know what we're talking about. When we're saying binomial, we know we're talking about two terms. When we say trinomial, we're saying three terms. And a polynomial means I can have any amount of terms I want, basically more than one term. So an example of this would be 4x squared plus 3xy plus 7y squared plus 14x plus 12y plus 3 equal to 0. This is an actual function, but it's still considered, because it's an equation side, it's then be considered a polynomial equation. But if we're just talking about the polynomial itself, it's without the equals 0 part. So it's not until we add the equal sign does it become an equation. Right now it's just an expression. So this is a polynomial. So in class, what you should have done is you should have worked on Khan Academy to work through the processes that you needed in order to understand how to multiply two terms, or two polynomials, I should say. And so that's what I'm going to go over right now in an example. So when you multiply two polynomials together, oops, wrong one. When you want to multiply two polynomials together, what you do is, let's say, it's exactly like you would think. You use the distributive property. So far, all I've showed you is how to multiply a monomial with a binomial. That's as far as we've gone. So to show you something a little different, let's say I have, instead of just a monomial times a binomial, let's say I have a binomial times a binomial. This is a method that will help you to remember how to multiply this, but it's a common method you'll it's a common method you'll use a lot. But it's just a way to help you remember what you're doing. But all you really have to remember to solve this is you're going to distribute. And some people use what they call FOIL to help them remember what to multiply. So this FOIL method means you multiply the first two terms. So you'd multiply x and x. So you get x squared. Or I'll just write it out, x times x. And then you multiply the outside terms. That's x and negative 3. So this is negative 3 times x. And then you multiply the inside terms, which is 2 and x. So this is plus 2 times x. And then you multiply the last terms, which is going to be plus 2 times negative 3. And so a lot of people use this FOIL method to help you remember what you need to multiply, but really all you're doing here is distributing. So if you just remember you need to take each term from the first binomial and multiply it to each term in the second binomial, you'll be fine. So this gives me x squared minus 3x plus 2x minus 6. Combining like terms, I get x squared minus x minus 6. So that's multiplying a binomial by a binomial. 2 term times a 2 term. And let me just show you a trinomial times a binomial. the same method applies, only now I have 3 terms in my trinomial. So let's say I have x plus 2 again, but this time I have x squared plus 2x plus, let's see, negative 24. Actually, I'm going to say this is minus 24. Okay? So what I do here is just like we did in the last slide. I take each term and I multiply it to the other term in the other binomial. But here I have a trinomial. So I'm going to take each term in the first and multiply it by each term in the second polynomial. So I do x times x squared plus x times 2x plus x times negative 24. Then I do the same thing. I'm going to do, I just did with 2. So I do 2 times x squared. So this is plus 2 times x squared. And then 2, so plus 2 times 2x. And then 2 times negative 24. So this is plus 2 times, I'm running out of room. Hold on one moment, sorry about that. There we go. Times negative 24. Now I just have to finish my multiplying and combine like terms. So then x times x to the second power, if you remember from our exponents, is x cubed. And x times 2x, the 2 doesn't have anything to multiply by, so it just stays 2. But x times x is x squared. And then x times negative 24 becomes a negative 24x. And then 2 times x squared is just 2x squared. And then 2 times 2 is 4 times my x is 4x. And then 2 times negative 24 is negative 48. Okay? So now I look to see if I have any common terms. I don't have any common terms with x cubed, so I leave it alone. Then I look, do I have any 2x squareds? Or any other x squared, excuse me, not 2x squareds, just x squareds. I have another x squared here, so I'm going to do 2x squared plus 2x squared. That gets me 4x squared. Then I go through, do I have any x's with the negative 24x? I have another 4x. Negative 24x plus 4x gives me a negative 20x. And then lastly, I have gone through everything but the negative 48 as my answer. And so this would be the final answer. Once you multiply everything through, you have to make sure you combine like terms. So I've done a binomial problem where I multiplied 2 binomials together for you, and I've done a trinomial where I multiply a binomial times a trinomial. Now this same method applies if I do 2 trinomials together. You take each term from the trinomial and multiply each term to the second trinomial. So basically, I think that's pretty much it for this video. I'm going to show you your multiple choice question here. So here's your multiple choice question for today. Pause the video now and just kind of do the problem real quick. If you need some help to go back and check to see how to do this, just rewind the video a bit and look at my example for the binomial times a trinomial. And this one's a little bit of a challenge, but I want you to describe how you solve this question. So pause the video here just to kind of get an idea of what the problem should be like, and then go ahead and solve it, and make sure you fill out that form below the video here. Also, make sure you follow the rubric for question 4. Have a good night.